Alright, so this is our last video on vectors. This is just showing how 3D vectors work, but essentially it's the exact same as our 2D vectors. We've just got an extra line, that's all. So I've got quite a few examples, so let's just jump straight to it. So we've been given two vectors here, A and B, and I want to find the following resultant vectors. So the first one, I've got A plus B. So I'm going to swap out the A, form the component form, so that 5, 2, minus 1. And that B as that minus 8, 4, and minus 6. So then I'm just going to add together the corresponding parts of my vector. So 5 plus minus 8. So 5 plus that minus 8, that's going to be minus 3. Then I've got 2 plus the 4, that's going to be 6. And then lastly, I've got minus 1 plus minus 6, that's going to be minus 7. So as you can see, nothing has really changed here. So let's take a look at the next one. It's going to be 5, 2, minus 1. And I want to take away my vector B, that minus 8, 4, and minus 6. So reading along, I've got 5 take away minus 8, double negative there. So that's going to be a positive. So 5 plus 8, that is going to be 13. Then I've got 2 take away 4, that's going to be minus 2. And then lastly, I've got minus 1, take away minus 6, double negative there, so minus 1 plus 6 is going to give me 5. All right, so next one here, I've got 10 times my vector B, so that minus 8, 4, and minus 6. So just multiply each little part by 10, so that's going to be minus 80, 40, and minus 60. And then last one here, I've got half of B take away A. So it's going to be half of my B is minus 8, 4, minus 6. And my A is that 5, 2, minus 1. BODMAS, got to do my multiplication first. So half of negative 8 is minus 4. Half of 4 is 2. And half of minus 6 is minus 3. And then doing that subtraction, minus 4 take away 5, that's going to be minus 9. 2 take away 2 is 0. And minus 3 take away negative 1, double negative there, that's going to be a minus 2. All right, so let's take a look at the next example. Here I've got two vectors are given by u, which is 3, 10, minus 2, and u plus v, which is 5, 2, minus 3. Find the vector v. So if I think about that resultant vector I have, I want to get the v on its own, and in order to do that, I need to take away that u to get rid of it. So my vector v is going to be that u plus v take away that u. So u plus v is that 5, 2, minus 3, and that u is going to be 3, 10, and minus 2. 5 take away 3, that's going to give me 2. 2 take away 10, that's minus 8. Then minus 3 take away negative 2, double negative there, that's just going to be minus 1. All right, last couple examples then. Here I want to find the magnitude of r. So this is the main reason why we set up all our magnitudes not as Pythagoras' theorem, but taking influence from it. It's because if you just remind yourself, I square all the parts of my component vector, add them together, square root it. It means when it comes to the 3D vectors, it's nothing new you have to think of. It's literally the exact same. So I want to square all these elements and add them together. So that's going to be 81. And remember, double negative on the there is going to be a positive. So that's just going to come out as root 86. And so the square root of 86 is just going to come out as 9.2736 and so forth, which is just going to be, to two decimal places, 9.27. Same idea here. Magnitude of m, I square all the elements, so 11 squared plus 5 squared plus that minus 7 squared. So that's going to be 121 plus 25 plus 49. And so that is just going to be the square root of adding together. So that's going to be, let's be lazy, 121 plus 25 plus 49, 195. Putting that into my calculator, and that is just going to come out as 13.9642 and so forth. And so that's just going to round to 2 decimal places as 13.96. So as you can see, the 3D ones, it really doesn't change anything. It is just you've got that one extra number to deal with, but that's it. Let me know if you have any questions, and good luck with the work.